distance. Vernon is at the top deck of a cruise ship and observes two dolphins following each other directly away from the ship in a straight line. Vernon's position is 154 meters above the sea level, and the angles of depression to the two dolphins are 35 degrees and 36 degrees. Question says, find the distance between the two dolphins to the nearest meter. So here we have two objects that we're trying to find the distance between. So we're going to have multiple triangles. We're going to have the triangle that goes to the first dolphin, and we're going to have the triangle that goes to the second dolphin. One with an angle measurement of 36 degrees, one with an angle measure of 35 degrees. Now, the interesting part is the distance between the two is really this little red section right here. We have the green triangle that goes from M to this spot. We have the blue triangle which goes from M, but it's still turning green, that comes over here. And if they're both here, if they're the two dots signify where the two dolphins are, the distance between them is really the red distance in between. Now, to find that, if we somehow could find, let's say, some intermediate values, like if we called from here to here x, and we called from here to the end z, and we called the little red part just y, then we really would find that we have y equal to z, which is the entire length, minus x. And that's what we're going to do here to solve for those two distances. Okay, setting them up. Tangent of 35 is set up for the other one, 154 over JL from the picture. Solving then, multiply each side by JL, divide by tangent of 35, and we're left with JL is approximately 219.93 for the distance. We'll do the same thing for the other triangle then, this time with a angle of depression of 36 degrees. Okay, solving here then, we have KL being approximately 211.96. So now we got to take a look at the distance between the two. And since the distance is really JK minus KL, as I was talking about before, then we have 219.93 minus 211.96, or about 8 meters in between. So the distance between the two dolphins is about 8 meters. So the same type of setup of finding the distance for one figure we can do for multiple figures as well, and then just subtract the distances to find the distance between the two of them. It's a complex problem with many steps, and we're going to do another one. A balloon. So the hot air balloon is floating above the ground at some height h. The balloon is anchored down by two ropes 2.8 miles away from one another. Let's call the two anchor points A and B. The angle of elevation from anchor point A and the balloon is 28 degrees. If an altitude was dropped from the bottom of the balloon to the ground, it would be at 1.8 miles from point A. Find the height of the bottom of the balloon and the angle of elevation at point B. So we have a lot of stuff happening here, and again, it comes down to the picture. So we have a balloon up there. So let's draw again that hot air balloon. It says that the balloon is anchored down by two ropes. So we have two ropes coming down from the balloon. And the two ropes are 2.8 meters apart. 2.8 miles, excuse me. We're going to call the 2 points A and B. So we'll call the right one A and the left one B. Angle elevation from anchor point A to the balloon is 28 degrees, so we have 28 degrees here. If there is an altitude drop from the bottom of the balloon to the ground, it'd be 1.8 meters, 8 miles from point A. So that means from here to here is 1.8, leaving us with 1 mile from B to the center point. Let's call it center point C for now. Two questions they're asking. It says find the height to the bottom of the balloon, so we're trying to find the height here, and the angle elevation at point B, so we're trying to find x there. So x degrees and h is our height. So that is our picture. And now we will use what we know about trig metric functions to solve for both h and the x. Let's go to the next slide here. Here's a little better picture drawn up. Same type of information, exactly how we laid out on the drawing. Let's start with the height. From A, we know that this is the opposite side, and we have the adjacent as 1.8, so therefore the tangent of 28 is equal to h over 1.8 miles. Solving then, we know that h is equal to 1.8 tangent 28, or approximately 0.957. Why did we solve for that first? Well, now that we know that h is 9.57, and we know that from point B to the middle is 1, we can use then tan inverse of x to solve for x. So we have tangent of x equal to 0.957 over 1. Tan inverse of that then gives you an approximate value of 43.74 degrees. So we need to solve for h to be able to use the trigonometric inverse for x. Alright, last example here. Says Madison looks out her second floor window, which is 15 feet above the ground. She observes two parked cars. One car is parked along the curb directly in front of her window, and the other car is parked directly across the street from the first car. The angles of depression of Madison's line of sight to the cars are 17 degrees and 31 degrees. Find the distance between the two cars to the nearest foot. So let's draw the situation here. We have a 15 foot apartment, or 15 feet above ground until her second story. Then she sees two cars. So we have line of sight to the two cars. We'll put a car here, and we'll put a car here. Now we're trying to find the distance between the two cars. So if we draw the two triangles in blue here, the distance that we're really trying to focus on is the one highlighted in green. Two angles of depression. The first one is 17 degrees, and the second one is 34 degrees. So if we take the distance of the triangle with 17 degrees as the angle of depression and subtract away the 34 degrees one, we should be left with the measurement we're trying to solve for. If we call the entire length z, the short length x, and the length I'm trying to solve for y, then we should be able to state that y is equal to z minus x. So now let's define both z and x then. Taking a look at just the triangle with z, we have this setup, z, 17, and 15 feet above ground. Using trig here, the tangent of 17 is equal to 15 over z. Solving by multiplying by z on both sides and dividing by the tangent of 17, we're left with z is equal to 15 divided by the tangent of 17. Similar to that, if we take a look at the second triangle, we'll have 31 degrees and 15, and we're solving for x. We can state that the tangent of 31 is equal to 15 over x. Simplifying by multiplying both sides by x and dividing by tangent of 31, we're left with x is equal to 15 divided by the tangent of 31. Now that we have both z and x defined, we can write a statement with both, and we'll go up top to write that. That is y, which is my distance, is equal to z, which is 15 over tangent, so 15 divided by the tangent of 17 minus 15 over the tangent of 31. This approximate value then, once we put that in our calculator, is approximately 24.098. And if we wanted that to the nearest foot, it would be b, 24 feet. And we'll get the arrow to drop in. 24 feet. Angle of depression, the distance between the two cars. This again is another example of using two angles to solve. Alright, that finishes lecture for today. We'll take a look at page 577, numbers 1 through 21 next time. Thanks for watching.